Assalamu alaikum everyone. In this video we'll see the different types of matrices. Okay, we have got many different types of matrices. Okay, so let's see. The first one, rectangular matrix. Rectangular matrix matlab jisme the number of rows are not equal to the number of columns. In a matrix we have got rows and columns, right? We have got rows and columns, right? So the number of rows are not equal to the number of columns. We know this, it is very simple. Right, the number of rows, suppose the rows are indicated with m and the columns are indicated with n. So the number of rows is not equal to the number of columns. Suppose here example, here if you see we have got 2 rows but we have got 3 columns. So 2 is not equal to 3 here, right? So this is a rectangular matrix. Dignity we can say it is a rectangular matrix, but for definition the number of rows are not equal to number of columns. Clear? Next, the square matrix. The number of rows are equal to the number of columns. Okay, for example, this here we have got 2 rows and 2 columns. So obviously 2 is equal to 2. Okay, we can have 3 by 3 matrix. We can have 4 by 4 matrix. I took an example of 2 by 2. Okay, in a square matrix, I'm saying we can have 3 by 3, 4 by 4, 5 by 5, like that. The number of rows should be equal to number of columns. Clear? Next, row matrix. Row matrix means you will have only one row and you can have any number of columns. Okay, so here single row and any number of columns. We indicate a matrix with m by n, right? So I've got only one row. So okay, instead of writing m, I'll write 1. Okay, 1 by n. N number of rows, so n, 1 by n. For example, here if you see, we have got only single row here. This is single row, and how many columns do I have? 1, 2, 3 and 4. I've got 4 columns. So this is 1 by 4 matrix, also called as row matrix. Only one single row, but I can have multiple columns. This is one column, this is one column, this is one column, this is one column. I've got 4 different columns. So this is a 1 by 4 matrix. That is nothing but a row matrix. Opposite of that, column matrix. If I have only one column and any number of rows, that will be a column matrix. Okay, single column and any number of rows. So obviously I represent a matrix with m into n, I mean m by n. So here my m can be any number of m's, rows can be more than 1. Okay, so I'm writing simply m. This m can be 1, 2, 3, 4, 5, anything. But whereas the columns, that is n, is only single column. So instead of writing n, I'll write 1. Okay, m by 1 matrix. M by 1 matrix is nothing but a column matrix. For example, here if you see, I've got single column but I've got multiple rows. This is one row, this is one row, this is one row, right? So here I've got 3 rows and 1 column. So this is 3 by 1 matrix, also known as column matrix. Easy, right? Next one, null matrix or zero matrix. Matlab all the elements of the matrix will be 0. The matrix can be of any order. Okay, m by n order, any order, 2 by 3, 4 by 5, any number of order, any order, but the elements present in that matrix will be 0. All the elements will be 0. Okay, if all the elements are 0, then it is called as a null or zero matrix. It is indicated either O or O m n, order of mn. Okay, mn. Okay, here the mn will be whatever the order I have. So here I have got order 2 by 3. So O of 2 by 3. Okay, this is a 2 by 3 matrix and all the elements present in the matrix are 0. So this is nothing but a null or zero matrix. Clear? Easy, right? Next, diagonal matrix. Diagonal matrix matlab in a square matrix, any square matrix if you say take, the matrix should be square matrix. यहाँ पे condition given है, specified है. In a square matrix, all the elements except the principal diagonal are 0. Matlab all the elements except the principal diagonal are 0. We have got diagonals, many diagonals. Suppose I am taking a 3 by 3 matrix. 3 by 3 matrix, the number of rows, the number of columns are equal. So that means it is a square matrix. Up square matrix mein the principal diagonal, here this is nothing but the principal diagonal. Right? This is also a diagonal, this is also a diagonal, this is also a diagonal, this is also a diagonal. We can have many diagonals, but from that principal diagonal I'm talking about. Okay, if the principal diagonal, apart from the principal diagonal, all the elements that are present, if they are 0, then this matrix is called as a diagonal matrix. डायगनल में आपके पास एलिमेंट्स होने चाहिए, उसके अपार्ट all the elements, the rest of the elements will be 0. Easy, right? But the condition is what? It should be a square matrix. Okay? Next, scalar matrix. Same thing. Scalar में what will happen in a diagonal matrix? आप कोई भी diagonal matrix ले लो. In a diagonal matrix, the diagonal elements is equal to a scalar. Any number, for example, I have got here. Example of scalar is this. This is a square matrix or this is a diagonal matrix. Diagonal matrix क्यों बोल रही हूँ मैं यहाँ पर? See, the principal diagonal elements, apart from the principal diagonal elements, all the elements are 0. So obviously it's a diagonal matrix, right? Also it is a square. So ठीक है, diagonal हो गया. For diagonal it should be a square matrix. For a scalar matrix it should be a diagonal matrix. So दोनों भी है. It is also a square matrix. It is also a diagonal matrix. So now I can see the condition of scalar matrix. Scalar matrix में the diagonal element should be a scalar. Any number. Suppose k. यहाँ पे I wrote k. Instead of k, suppose I've got 5. K can be anything. It can be 1, 2, 3, 4, anything. Suppose I took k. Suppose I took 5. So the principal diagonal have got a scalar value. The same value. 5, suppose 5, 5, 5. Suppose 3, 3, 3. ठीक है? Getting clear? If the principal diagonal elements are same, then it is nothing but a scalar matrix. Okay? Next one. Identity matrix. या आप इसको unit matrix भी, you can call it as unit matrix as well. Okay, so identity or unit matrix में in a diagonal matrix, the diagonal elements is unity. Identity 1. Unity 1. याद रख लीजिए आप इसको. Unity बोलिए या identity बोलिए, one and the same. मतलब क्या है? The diagonal element should be 1. The rest of the elements should be 0. Okay, in a diagonal matrix we are saying, we are specifying a condition here again. The diagonal matrix. In a diagonal matrix, all the elements, all the diagonal elements should be what? 1. And the rest of the elements, obviously it will be 0 because it's a diagonal matrix. ठीक है? I'll represent it either with I or in, where n is nothing but the order. ठीक है? Order of a matrix. It's a 3 by 3 matrix, so I'll write I3. Okay? Clear? The diagonal elements will be 1. Sorry, the diagonal elements will be 1 and the rest of the elements will be 0. So this is nothing but an identity matrix or unit matrix. ठीक है? Represented either with I or in. Easy, right? आगे के नहीं रहते. Kidding. Let me just erase this and write down the rest of the types. Okay, the next one is symmetric matrix. मतलब a square matrix. It should be a square matrix. Okay, again we have got a condition. In a square matrix, the I comma jth term is equal to the j comma ith term. Okay, if I inverse it, suppose that means a of ij should be equal to a of ji. ऐसी matrix को I'll call a symmetric matrix. Let's see an example here. See, this is my symmetric matrix. 1 minus 3 minus 4 minus 3 2 minus 5 minus 4 minus 5 3. This is a matrix. Let's check how it is symmetric. Suppose we'll take one element, any element. Suppose 3 1. Okay, third row first column. Suppose 3 1. Then the element that is 1 3 should be equal. ठीक है? अगर मैं 3 1 element लूँ, the element present at third row and first column, then the element present at उसका inverse, first row and third column should also be equal. ठीक है? Not only this, for example, I'm saying. So let's check. A of 3 1, I'm saying the third row, first, second, third. Okay, third row, first column. So the element is -4. ठीक है? -4. अब if I see a of 1 3, then it should also be -4. ठीक है? Getting? Let's check. First row, third column. This is the first row and this is the third column here. So if you see, both are what? Equal. In same way, all the elements, any I comma j element should be equal to j comma ith element. Clear? Easy? Next. Let's see skew symmetric matrix. Same thing in a skew symmetric matrix. In a square matrix, the ith comma j term should be equal to minus of j comma ith term. There should be a minus here. Okay? Ith comma j term should be equal to minus of a comma a of ji. Okay? J comma ith term. Clear? Let's check. Same thing we'll take here. A of 3 1. should be equal to minus of a of 1 3. जो भी element a of 1 3 पे present है, that should be minus of that term. ठीक है? Clear? Let's check it. This was an example of symmetric. This is an example of skew symmetric. Let's check. Here, if you see, suppose 3 1 I said, right? Third row. This is the first, second, third. This is the third row and the first element. Third row, first element. It is minus 5. ठीक है. Then the element that is present on the third row, first column, first row, third column should be what? The inverse. First row, third column should be what? Minus of this element. So minus of minus 5 should be plus 5. So the element present at A of 1 3 should be plus 5. Let's check. 1 means first row, 3 means third column. So see here, yes, it is plus 5. Clear? Getting? Symmetric and skew symmetric. One more thing, if you notice here, in skew symmetric, the diagonal elements are 0. How? Let's see here. Let me make some space. So here, if you see, the diagonal elements, right? The diagonal elements are 0. Diagonal elements matlab a of ij and a of ji, both are equal every time. ij या ji एक ही है यहाँ पे. I is 1, j is 1. Here, I is 2, j is 2. Second row, second column. Here, I is 3, j is 3. Same thing. I is 1, j is 1. I is 2, j is 2. I is 3, j is 3. Diagonal में वैसे ही होता है, right? So, instead of writing C, both are equal. It is either 1, 1, A of 1, 1, A of 2, 2, or A of 3, 3. Both I and j are same. Instead of writing them as A of ij, I'll write A of I. Because both are same, right? I और j दोनों same है. I can write ijj or I can write aii. So I can write aii or I can write ajj. Okay? कुछ भी, because both are same. Instead of writing ij, I'll write either I, I'll write either j. Clear? Now, we said in a skew symmetric matrix, this A of I should be equal to minus of A of II. ठीक है? I'm representing only I told you. So A of II should be equal to minus of A of II. So what happens? I'm sending this minus I to this side. What happens? This is minus. Comes to this side, it will be plus. So A of II plus A of II is equal to, there is nothing left here. So let this be 0. Nothing matlab 0, obviously. So here if you see, A of II plus A of II is nothing but 2A of II is equal to 0. I don't need this 2. So I'm sending this 2 to the other side. What happens? Here it is multiplying, goes to the other side, divides. 0 divided by anything will give you 0, obviously. So what happens here? A of II is equal to 0. अब इसका मतलब क्या हुआ? Any element that is present at A of II will be 0. अब चाहिए I can be anything. Suppose I is 1. So A of 1 1 is 0. Suppose I is 2. So A of 2 2 is also 0. Suppose it is 3. A of 3 3. It is also equal to 0. Because we got this condition. A of II is equals to 0. We got this condition. So check here. A of 1 1. मतलब first row first column. 0 0. Condition checked. It is not a condition. Next one. A of 2 2. Second row first second. This is the second row. Second column first second. Second row second column. See, the element is 0. Because the condition A of II is equals to 0, so obviously this element is 0. Same thing, A of 3 3. Third row third column. Element is 0. Understood how we got the diagonal element as 0? All the diagonal elements are 0 in a skew symmetric matrix. Get it? Clear? Now, so symmetric is done, skew symmetric is done. In symmetric, A of ij is equal to A of ji. The term A of ith j term is equals to A of jth term. And the opposite, A of ij term is equal to minus of A of ji term. Clear? Next. And condition, don't forget, it should be a square matrix. I'm only talking about the square matrix. It should be a square matrix. No rectangular matrix, no triangular matrix, no nothing. Okay? Only square matrix. Next one, triangular matrix. Triangular matrix matlab it won't be like this. Okay? It won't be like a triangle. The elements will be in a triangular form. Here, every element above or below the diagonal element is 0. ठीक है? Okay, we have got a diagonal element. वो diagonal element के above or below elements will be 0. ठीक है? See here, we have got two different types in triangular matrix. One is upper and the other is lower. Upper means what? The elements, जो भी elements रहेंगे आपके below the diagonal element will be 0. ठीक है? Here example. Here. This is my diagonal element. The elements that are present, whatever elements present below the diagonal is 0. अगर below diagonal element 0 है तभी तो ऊपर का triangular बनेगा, right? Obviously, right? So that's why the below elements, diagonal के below elements will be 0. उसका opposite, the elements that are present above the diagonal elements are 0. मतलब क्या हो जाएगा? It will be a lower triangular matrix. ये triangle हो गया. इसके ऊपर के, if this is diagonal, इसके ऊपर के elements अगर 0 है, तो if you see, this is a lower triangular. If you see here, this is an upper triangular matrix. Triangle के form में है. This is forming a triangle, right? Here it is forming a triangle, right? So this is lower triangular, this is upper triangle. Clear? Easy. Next. Transpose of a matrix. Transpose of a matrix, matlab we all know this. We have studied this in our 9-10 standards. Transpose of a matrix means what? Interchanging the rows and columns. The rows will be changed to columns and the columns will be changed to rows. Okay? And it is denoted with A power T. Okay, suppose my matrix is A, then the transpose of that matrix will be A power T. Okay, suppose this is my matrix. I have got how many rows? 2 rows, and I've got 1, 2, 3, 4. 4 columns. So now what happens? This is 2 by 3 matrix. Matlab 2 rows, 3 columns. So what will be the transpose? 3 rows and 2 columns. Get it? Interchanging. The rows are changed to columns. The row is changed to column. Get it? Interchanging of rows and columns. Easy, right? Next one. Conjugate of a matrix. Matlab kya? Every element is replaced by its conjugate complex number. Conjugate matrix में you will get complex numbers. मतलब imaginary numbers. ठीक है? For example, let's take this. Suppose this is my matrix. It is a what? 2 by 2 matrix. 2 rows and 2 columns. Right? So I've got a conjugate number here. These are nothing but the imaginary numbers. I आ गया आपके पास imaginary numbers, right? It's a complex number. So this is suppose my given matrix. So its conjugate will be what? Just simply changing the signs for you to remember. यहाँ पे 1 plus 2i. So this becomes what? 1 minus 2i. Here I've got minus 4. Here I'll have plus 4. 3 is an integer, doing nothing to this. Now 1 minus 2i. So 1 plus 2i, changing the signs. Get it? Easy, right? Next one. Conjugate of a matrix is done, and it is represented with a bar. Okay, if suppose my matrix is A, then this will be a bar. The conjugate complex will be a bar. Okay. Okay. The next is conjugate of a matrix. Yeah. Transpose of a conjugate or conjugate of a transpose. दो भी आ जाएंगे, conjugate and transpose. आप या तो पहले transpose करिए उसको, then conjugate करिए, या फिर conjugate then transpose. Your wish. Suppose this is a matrix given. यही matrix को हम consider करेंगे. This is my matrix given. First I am going to change into a conjugate matrix. ठीक है? Conjugate complex. Done. Now transposing. Transpose अगर मैं करूँ, so the rows will change into columns and the columns will change into rows. So this is my row. Let's change into column. 1 minus 2i by मतलब नीचे 4i. ये row changed into a column. Next, second row will be changed into a column. 1 plus 2i. ठीक है? Now this final matrix is nothing but my conjugate matrix, which is represented with A star. Clear? Getting? This is not it. We have got some more types. Okay, let me just erase this and draw the rest. Okay, so the next type of matrix is Hermitian matrix. मतलब conjugate transpose any matrix जिसका conjugate transpose is equal to itself. ठीक है? मतलब क्या? Suppose you have got a matrix. Suppose that matrix is denoted with A. ये matrix पे if you are applying conjugate transpose मतलब conjugating then transposing or transposing then conjugating, we saw this previously, conjugate matrix. ठीक है? If you are applying that thing and it conjugate transpose is denoted with A star, right? We know this. Conjugate या conjugate transpose कुछ भी बोलिए आप, that is denoted with A star. If a matrix is given and applying conjugate on this मतलब conjugate transpose, then I should get what? The matrix itself, the original matrix. ठीक है? Such type of matrices are called as Hermitian matrix. ठीक है. Next one, skew Hermitian matrix. मतलब क्या? Skew, we saw this. Skew symmetric. Same thing. Again, when I'm applying to my given matrix, if I'm applying conjugate transpose, then it should be equal to what? Minus of itself. यहाँ पे it is equal to itself, the original matrix, but in skew Hermitian it should be minus of that matrix. Get it? Easy, right? Skew symmetric and skew Hermitian. Get it? And yes, in skew symmetric we said that the diagonal elements are 0. We proved it. How the diagonal elements are 0. In this case also the diagonal elements will be 0. Okay? Clear? Next. Yeah, and one more thing. I am talking about the conjugate. मतलब you'll get imaginary numbers here. यहाँ पे conjugate transpose मतलब the matrix which will be in an imaginary form, जिसमें imaginary elements will be present. Okay? Conjugate elements, imaginary elements. Okay? Done? Clear. Next. Idempotent matrix मतलब a matrix when multiplied by itself yields itself. कोई भी matrix आप ले लें. Suppose you have got a matrix A. If you are going to multiply that matrix with itself, ठीक है, then what you should get? The original matrix. A into A is what? A square. So A square should be equal to A. When you are multiplying a matrix by itself, it should yield itself. मतलब it should give you the same answer, the original matrix. Okay? For example, let's take this. I have a matrix 1 0 0 1. If I'm going to multiply this matrix two times, if I'm going to multiply the matrix by itself, 1 0 0 1 is being multiplied with 1 0 0 1. I should get the same answer. I'll get the same answer only. See here. if you don't know how to multiply a matrix, this row will be multiplied with this column. See here, 1 into 1 will be 1. Then 0 into 0 is 0. 1 plus 0 I'll get. ठीक है? Next, this row will be multiplied with this column. The second row will be multiplied with second column. Next, first row will be multiplied with the second column for this one. 1 into 0 is 0. Plus 0 into 1 is 0. So 0. 0 plus 0. Next, second row will be multiplied with the first column. So 0 into 1 is 0. Plus 1 into 0 is 0 again. Right? Next, the second row will be multiplied with the second column. What you will get? 0 into 0, 0. Plus 1 into 1, 1. So if you see here, what you will get? 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1. You got the same matrix, the original matrix. Clear how we are getting? If I am multiplying the same matrix by itself, I should get the original matrix, the same matrix. Easy, right? So this is an example of idempotent matrix. There are so many, right? But this is not it. We have got so many more. I am not going to illustrate all the matrices, all the different types. These are enough. ठीक है? For practicing this linear algebra or matrices, this many are enough. But there are more. Okay? And saying this again, there are more matrices. There are more different types of matrices. I only listed till I. ठीक है? Okay? I think it is clear. So that's it for this video. Inshallah, in the next video, we'll talk about what are ranks and how to find the rank of a matrix. Okay? Thank you.